Okay, so this set of notes, like I said, it shouldn't take too long. This is over groundwater, which, as you may have guessed, you find in the ground. This is water that's underground and in the ground. This next one. So while this diagram is maybe a little cartoonish, it does serve its purpose. Before we get too much deeper in this, because I've had students ask about this in the past. So the groundwater is referred to as the aquifer. And this isn't something that if you dig down just anywhere, you dig in the ground, and if you dig, when you get to the aquifer, it doesn't open up into some sort of a cavity or a huge cave and there's this water under there, and that's what the aquifer is. Now, while there are some caves that have water in them, yeah, but the aquifer is water that is in rock, it's in soil, it's in all of that. So, if you dig down deep enough, you'll get into the aquifer, but it'll still be, solid material. Kind of like if you filled like if you fill a glass with sand and then put water in it to the very surface of the sand and put some more sand in, it would kind of be like that. There's it's material. It's not like just open space where it's filled up with water. You couldn't go down there and swim around or anything like that. Or kind of like if you put sponge in water, it's the sponge is saturated, but it's not just open water. So with that being said, the aquifer is, it's saturated material, saturated rock, saturated soil that's above the bedrock, because basically the bedrock seals the water, above it. It doesn't let it, infiltrate and penetrate the ground anymore. So in this next one of the terms that you hear a lot with any sort of discussion about groundwater and aquifer is the term water table. What that is basically, it's just the top edge or top boundary of the aquifer. So above that, we call that the zone of aeration. So any sort of sediment or rock or anything like that in the zone of aeration, in the spaces between sediment and the spaces within rock and all that, it's filled with air. There's nothing there. Whereas below the water table in the zone of saturation, any spaces between sediment or in rocks is filled with water. That area is saturated. So something to remember about the water table is that it changes, it rises, it falls. As there's more rain or snow melts or anything like that, the water table will rise some. Whenever it's been dry, during the summer, or if there's been a drought, the water table will be depleted and it will drop. So in more rural areas, so places not in the city where people just have city water, some people have to have wells. So they have a company come out and they drill down into the ground and they attach a pump to it, and they drill down deep enough to get into the zone of saturation, so when they turn on the water comes out. What happens sometimes in areas that haven't had a lot of rainfall and have had droughts and things like that is, if this is the water table and this is the well that used to be below the water table, well, now the water table is dropped. So now the well is in the zone of aeration. So, they turn on the water and nothing comes out because there's no water to pull up. So then they have to have a company come out and then they dig deeper, or they drill deeper to get a deeper well to get back into that zone of saturation. So the fact that water table moves around a lot, or can rise and fall, it's something to remember. But it does tend to fall a lot faster than it rises, just because of the amount of water that people use. Pretty much, a lot of it goes for irrigation, for farming. That's a big one. But all right, next one. This one just kind of shows with the water table and this river, any type of surface water, like a river, stream, pond, lake, that sort of thing. The surface of that water is usually pretty close to where the water table is. If it's, it's not going to be lower than the water table because it would fill up to that point. It's not typically going to be higher than the water table, because that means that it would have to be, completely contained within something that was impermeable and wouldn't let any of that water escape. And it would have to be fed only by like rainwater. So they're usually, right about the same. And then this other part of this diagram with a spring, I'm sure we've all heard of spring water and things like that. This is one type where there's a layer of rock or certain type of soil that is impermeable. It doesn't let water move through it, so it's holding that up and kind of containing it. And then slowly it kind of leaks out of that, either through kind of typically the side of a mountain or a cliff or something like that. Another type of spring is related to something called an artesian formation. And this is anytime the groundwater is under pressure. And the way that the groundwater is pressurized is because it's tilted. So like in this diagram, if you have the aquifer is tilted at an angle and it's kind of trapped between two layers of rock that don't let water through it. If you drill a well, towards the bottom of that, or if there's some sort of a break in the rock, there's all that water that's above that point, because it's at an angle, there's all that water that's above it and all the weight of that water pushing down on it. So if you give, the water a place to escape and release that pressure, the weight of that water is going to push that water out. And even in that same formation, if you were to drill a well higher up that slope, there might not be enough weight from the water above it, not enough pressure to force that water out. So it might not be an artesian well higher up the formation, but lower down it might be, and it might be pressurized there. So it just kind of depends on where in the formation either the spring forms or the well is dug. This next one we've talked about before, porosity. If we talk about something being porous, you're talking about it having holes like a sponge or something. So again, the porosity just has to do with the amount of space between sediment. And the bigger the sediment, the more space there is. If the sediment's really, really small, like clay, there's not going to be a lot of space between those pieces of sediment. Closely related to porosity is permeability. So porosity, we're talking about the space between pieces of sediment. Permeability is how fast water can move through those spaces. So bigger the spaces, more water can flow through it. It's pretty basic stuff there. If if something has a real big hole, lots of stuff can get through it. So different rocks have different levels of permeability. Some let water move through more quickly than others. Some don't let water move through it at all. Let's skip over that one. So then we'll go to some hot springs. which, you know, just like the name says, you know, this is one of those cases where in science, the name describes it for exactly what it is. It's a hot spring. It's, you know, water that comes out of the ground, but it's hot. Um, the reason it's heated up is because there's, you know, some sort of volcanic activity to some degree there that's heating up the ground and heating up the groundwater. Uh, if you look at this map, notice that in Indiana, we don't have any hot springs because we don't have any volcanic activity that's, you know, close enough to the surface that it's going to create, you know, any of these things. You see a lot of them in areas with mountains, you know, so there's some in the Appalachians. Um, there's Hot Springs, Arkansas, which is, you know, kind of an anomaly in there. It's kind of an outlier, but I mean that's where it got its name. You have some out in, you know, the Rocky Mountains, Yellowstone National Park in Wyoming. California has a bunch along the San Andreas Fault. You know, so anywhere that you have volcanic activity, you're going to have hot springs. Even places where there's earthquake activity, you're going to be much more likely to have some hot springs. Hawaii's another one. I mean, Hawaii, it's a giant volcano. That's what the whole thing is. So of course you're going to have hot springs. It's a giant volcano. So a couple of pictures of some hot springs. These are from Yellowstone National Park. The coloration is due to different organisms that live in the hot springs. So different bacteria or algae that lives that's the only place they live is in these really hot springs. But they like different temperatures. Different organisms like different temperature water. So, you know, ones that like the cooler water, I mean, comparatively speaking, they're going to live closer to the surface, whereas ones that like it, you know, just a little bit warmer, they're going to be a little bit deeper. So one of the reasons that you get different colors in kind of those rings because of the temperature, plus then also just the color of the water, and as it goes down it's going to, you know, be darker because there's more water. Paint pot, it's kind of a cool thing. It's basically, you know, hot spring water that's heated. It's hot spring, but then it's in soil that's rich in clay. But you get bubbles, and, you know, as gas escapes and it kind of boils over, it's kind of cool looking. If any of you have taken ceramics, it's kind of like a slurry, like just a mixture between clay and water that's real kind of runny. The next thing we're talking about hot springs and heated groundwater is a geyser. And a geyser is when, you know, there's an underground formation that will periodically fill with water. That water becomes heated to the point where it, you know, essentially erupts and sprays hot water and steam into the air. They're, you know, different size geysers. Some are, you know, relatively small. Some are really, really big. Again, Yellowstone National Park has the most geysers of any place in the world. Iceland is the second highest. But like I said, some are larger than others. I've not been there, but it would be a nice place to visit. This is one called Old Faithful. And it got that name because the period of time between eruptions was extremely consistent. Although that has changed gradually over the years, it now takes a longer period of time in between eruptions, and it's not as consistent just because of geologic changes, you know, underground, and with the amount of groundwater that can feed the geyser. But it does still erupt, and I mean, I think it shoots water and steam 200 or 300 feet in the air. So it's pretty impressive. All right, this next thing, karst topography. The main things to remember with karst topography is one that, well, it's not on here, but one is we have this here in Indiana. It's named for a place in Yugoslavia, but we have this here. I mean, there are a lot of places in the United States that have karst topography, and Indiana is one of them, because we have limestone bedrock. As a result of having limestone bedrock, we have cave formation, especially when you get into southern Indiana and then, on down into Kentucky. There are a lot of caves. You might be asking, well, why caves and limestone? I'm glad you asked. If you remember back, this is several sleeps ago, when we were talking about minerals, we talked about a mineral, calcite. Calcite's the mineral that basically glues together limestone. Calcite's a mineral that will dissolve in acid. So if limestone is exposed to an acid, it will dissolve limestone. You may be asking yourself, where's limestone going to come into contact with acid? I'm glad you asked. Remember when we talked about chemical weathering, we talked about the formation of carbonic acid. Raindrops fall through the atmosphere. Those raindrops come into contact with molecules of carbon dioxide. Molecules of carbon dioxide go into the raindrops, and that becomes carbonic acid, which is a weak acid. As that rain infiltrates the ground, soaks through the ground, comes into contact with limestone, it'll dissolve a little bit of that. So over time, over time, that limestone bedrock can, be dissolved and eroded and washed away, and that leaves caves behind. There are also a lot of other formations. We're not going to get into, formations within caves and stuff like stalactites and stalagmites and all that stuff. The main thing is just to know that there is cave formation because it's limestone. Not all caves are in limestone, but the vast majority are because of this process. One surface feature that is characteristic of karst topography are sinkholes. And these are things that we have here in Indiana. And again, a lot in southern Indiana, there are a lot of sinkholes. Some are big, some are small. But here are just a few pictures of caves. I actually don't even know where these caves are. But like here's a stalactite and stalagmite from the floor. When it started to become popular to go visit caves, like as a tourist, back in the early 1900s, they used to let people break off stalactites and stalagmites and take them as souvenirs. But they obviously don't do that anymore because there wouldn't be any left. In this picture, this is water that's reflective. It's not just like a huge cliff, even though it kind of looks that way. And these are obviously lit with, electric lights. It's not, they're a cave. There's no natural light down there. So I mentioned sinkholes, and essentially all a sinkhole is a cave where the ceiling of that cave has collapsed. It's one of those where, there's whatever supporting material below the surface is gone or mostly gone, to the point where it can't support its own weight, so it caves in. And like I said, we have these, around here. Now, some of these can be created by things that we do. A lot of it has to do with either some sort of a water leak or something to where we've changed the way water drains or where water drains, like, happening around construction sites and things like that sometimes, but they do occur naturally. So, here's another example of one. I would guess this one's probably more of a man-made one because of where it's at and kind of the size of it. Just a couple other ones. And some are, much larger than others. There's this one. Now, this isn't the one that I'm going to tell you about, but there was one in Florida. I don't know. It's been a while now, maybe, I don't know, 10, 12 years ago. There was a guy and he was asleep in his bed, and the corner of his house fell into a sinkhole, and the guy was never found. His brother was in the house, and his brother could hear him yelling down there, but he was never found. Or there was, I think it's Bowling Green, Kentucky. That's where Chevrolet makes Corvettes, where they make the car. And there's also a Corvette museum there. And there was a sinkhole that opened up like in the middle of the museum. And they have footage. You can Google it and find all kinds of videos. They have footage from security cameras, and the floor just kind of starts falling in, and then cars start falling in. I think there were 7 Corvettes or something that fell in. I mean, they didn't know that the cave was there when they built the building, but over time, it had just eroded more and more to the point where it couldn't support, the structure, so it fell in. And then I think there was a National Geographic thing or something to where, because they pulled the Corvettes out, and then I think they restored them because they were like collectors. They were like, one of a kind, or like the first one of this model or something. But just to show you that, I mean, it can happen, all over the place. One place that you do have a lot of them is in Florida. Florida has a really bad problem with sinkholes because they do have karst topography. They have, limestone bedrock. But Florida is, there's so much water. And the elevation, the highest points, in Florida really aren't very high at all. The whole state is really close to sea level. So they have a lot of places where they have some really big problems with sinkholes. I mean, there are parts where there are whole neighborhoods that have been built on land that they're now discovering has, really, really bad sinkhole problems. So it's an issue. And here's just another picture with, I think, some apartment buildings that look like they've fallen into, you can see the outline of it. So if that's an apartment building, I mean, that's a really big sinkhole. And some are really deep, some are shallow. It just kind of varies. But does anyone have any questions?